Welcome to the Infill Podcast, where we interview the most interesting members of the 3D printing and maker communities live and with audience participation. And now, here is your host, Jonathan Levy.
All right, welcome everybody. Let me figure out how to unhide myself. Hi everyone. How's everyone doing? Really excited to have you all here. I'm in the studio, as those of you watching on video can see, and I apologize for the mess, both personal and spatial. We have a really exciting episode for you guys today, but first I do need to start with the segment we always start with, which is What's Printing? Brought to you by Octo Everywhere. You guys get to see a sneak peek of upcoming projects that I have going, and also check out the functionality of Octo Everywhere. It's a win-win. And as you guys can see, I am printing a lot of multi-board. I have a huge project coming up where I'm going to be doing a ton of multi-board. So you can see one cool thing with Octo Everywhere is it allows you to remotely view all your printers at once with a preview. You can see the status, and you can see that AI is monitoring them. So across two different locations, I have printers operating, and they're all being monitored. Even my Bamboo Lab A1 Mini, I have AI monitoring it and telling me if there's any problems. You can see I'm printing a massive multi-board, and I'm even printing, we can go into the printers. One of the things I love about Octo Everywhere is it actually lets you tunnel into the printer and see real time. So I can see all the cameras. And this is very prescient given the topic of today's conversation. I'm actually printing my very own homemade RPLA. You can see it's a little bit stringy. It's not perfectly dried. But yes, I am printing my own homemade PLA, which brings us to the topic of today's conversation. Today, I am joined by Timo van der Laak. I'm sure I'm not pronouncing that perfectly, but he is the CCO of a company called 3Devo. You may have heard of them. They make recycling equipment, extrusion equipment, shredders, and we're excited to geek out about material science and 3D printing recycling. I know many of you are very interested in recycling your 3D prints. Today, we're going to talk about how feasible that is, why you might want to do it, and just how we can all get started. Timo, welcome.
Hi, Jonathan. Thanks for having me.
I'm really excited.
You did pronounce my name correctly.
Awesome.
I'm Timo van der Laak, indeed.
Awesome. Well, Timo, I'm really excited because I know, for those listening, you guys make a lot of industrial equipment or work with businesses, but I've been talking with members of your team. We were talking on Formnext. We've gone back and forth on email, and I know your mission is bigger. Tell me a little bit about yourself before we get into that, and tell me a bit about 3Devo. How'd you get into 3D printing? How'd you get into material science? Who is 3Devo? I'm just going to let you talk freely.
Yeah.
Yeah.
Where do I start? I think I'll just start with myself. So I studied mechanical engineering here in the Netherlands, and that's 3D printing was just starting to come up. The hype was starting. People were talking about it, but not a lot of people were using it yet. And I still remember during a project we had access to a 3D printer, but we were not allowed to touch it even. It was just, we had to ask the teachers for permission, because if we break anything, it costs thousands of euros to repair it. And yeah, it felt like magic. So then at one point I was looking for an internship, and I stumbled across 3Devo. And it was just a small startup at the moment. I think there were 6, 7, 8 people working. It's basically Tim, our CEO and founder, together with a bunch of interns, actually. And the filament maker won the first model just put on the market. So you could basically turn pellets, polymer pellets, into the small machine and turned it into filaments. And back in the days, filaments were super expensive. So we thought, okay, why can't people just create their own filaments to save money? So it was quite funny, because I didn't really have a lot of passion for 3D printing yet, because it felt so inaccessible to me. But then like Tim, he just asked me, okay, Timo, we just put this machine on the market. We need to find out what it can do. So
Right.
back in the days, we were just collecting customers, and they sent us all different weird materials, and they just want to find out, okay, this polymer that I have, or this special composition, can I turn it into a 3D printing material?
Mm.
So basically, I was in this little, yeah, weird kitchen area, and with a DIY fume hood to make it a bit safe, some gas gloves, and I was just in there for hours and hours and days testing the materials. And I don't know, it that's how I got into 3D printing actually. So very hands on, and as I was doing it, I started liking it more and more, because we realized that there's so much freedom in 3D printing, and
Yeah.
this adds another layer of freedom, because with 3D printing you're already not restricted anymore in terms of shape,
Right.
but with our machines you're also not restricted in terms of material, and that
Yeah.
opens up a whole new world.
So is the business case now for 3Devo, as I understand it, let me tell you, because you had told me before we hopped on, a lot of people have misconceptions about what 3Devo does, and obviously I don't want this to turn into an advertisement for 3Devo, but I do
Yeah,
want to understand, because as you know, I'm extremely passionate about filament recycling. It's kind of my thing. Like, let me just show people. Like, I'm
nice.
grinding my own regrind, and I'm extruding it into my own filament, as you could see, because I'm printing it on my Voron. I want to make sure I don't knock this over. I'm very passionate about 3D printing, recycling, and I would like to see. I mean, plastic recycling as a whole is broken, and I can't fix that. Ever since China stopped importing, which is their prerogative. I'm not blaming them. They didn't want to import
Yeah,
other people's waste, and the whole global plastic ecosystem broke as a result of
yeah,
that. Most people don't realize that, but look it up. So
yeah.
plastic is not recycled right now. I can't fix that, but I feel like I have a small enough, a reasonable enough platform, small, to kind of drive this. And right now, there's actually a pretty good solution out there for consumers to extrude their own filament. The ArtMay extruder is pretty good. Um, but I realize this is the longest question ever. There's no solution for a desktop shredder. And you guys make some great desktop products. As I understand it right now, coming back to my original question, right now
Mhm.
you guys are mostly focused on businesses that are trying to formulate their own filament, like to prototype, right? So I'm a polymer science company, or maybe an engineering company. I want to make my own special filament. Let's not put it on a big extrusion line. Let's test it on the engineer's desk.
Yeah,
Is that still true, or is that who 3Devo was?
it's
I don't know
it's
what that
it's where
was.
it started, I think.
Okay.
So yeah, it's like it started mainly in universities. So we sold a lot of machines to universities. Basically, almost any university you can think of worldwide has at least one of our machines.
Really?
Uh,
That's
yeah,
so cool.
it's, it's quite impressive, and so it's mainly used in the R&D setting to see, okay, can we turn materials into 3D printing materials, and that also opens up the world for using plastic waste, for
Right.
example. Can you actually turn plastic waste into 3D printing materials? And now, over the past years, our machines and our clients especially have proven that it is possible, but you
Wow.
just need to take a lot of variables into account, and it's not always easy. Um,
No. Easy, it is not. I've
no,
spent, the better part of 8 months, maybe 9 months, and many thousands of dollars building my own rig. So if that's where 3Devo was, I mean, let me focus on that for a second, which is, are universities buying these machines necessarily to, like, for the students to learn about formulating polymers, or are they using it to produce filament cheaper, or both?
Hmm. Yeah, so the cheaper part, I don't think so. So for
Right.
universities, that's why it was so easy to buy our machines for universities, because there wasn't really an ROI needed for the machines.
Okay.
They just need to get the experience and um,
It's
learn about the
literally about
company.
students learning, like, let's see how plastic is made in
Ex-
industry on a small
Exactly.
enough scale that it can fit in the lecture hall.
Exactly, and it needs to be
Fascinating.
fitting in a lab, in a lab, because
Yeah.
normal extrusion lines, they're like 20 meters long, maybe,
Right.
or a couple meters long, and yeah, you can't have that under a fume hood, for example. So there's
Right.
no way you can experiment with it. And also, sometimes you just they formulated a new polymer uh, for, I don't know, implants. This material sometimes
Okay.
costs thousands of euros per kilo,
Right.
and you don't want to process that on a big
On a
line, because
proper
then you're
line.
wasting.
That's
Yeah.
very interesting. So I'm gonna ask you a tough question, which if the answer is I maybe, if the answer is maybe, I'll accept it. But is there a future? I'm sure you saw the Loop, big, like, crowdfunding, if you could call it that, campaign, deposit campaign. There's a lot of talk about, is this a scam? There's now talk about, have they violated the open source license of the ArtMay extruder? But people are interested. I mean, there's a lot of talk about this. Is there a future where 3Devo makes, let's call it prosumer equipment for at home, or I don't want to say at home. I don't think it's ever going to be a case where an individual user is going to recycle their scraps, but 4 or 5 people who are in a local makerspace together. Is there
Yeah.
a future where we see a desktop shredder extruder combo for, under $2,000? Or is it just, you can't beat the laws of physics? It takes a lot of energy and a lot of mass to shred plastic.
Yeah, that's an interesting question, and I knew this was coming.
Of course.
But I think it's like a roadmap, right? It's first it needs to
Okay.
work, and then just like the 3D printers, like now, only now, the 3D printers are very cheap. Like anyone can buy a Bambu Lab printer, and
Right.
it works, right? But
Right.
first it needs to work first.
Yeah. I wonder how much, I mean, having gone through the whole process myself, and my shredder is in no way comparable to the products you make at 3Devo. It's garbage.
Yeah,
I mean, my shredder is garbage. The ArtMay is great. I'll say the ArtMay is, I don't know what you guys think about it, but it's, I think, in my non-engineering perspective, a very good product. And I think if I put through it high quality material, like when I'm very, very clean about my shredding, and I don't get metal chips and I don't get sawdust from, it works well and it gives consistent diameter. So shout out to David at ArtMay. But I wonder how much, because the shredding is such a challenge, I wonder how much of it is just, hey, you need a powerful motor to shred, 3D prints with 4 or 5 perimeters. This is a failed 3D print, which is basically solid, right? And motors are not something that are like, industrial scale motors are not something that's going to get cheaper. Now, maybe with innovation in terms of gearing, there's ways to do it, or maybe if the user is willing to take an angle grinder and cut up small parts.
mm,
But I mean, on some level, isn't it just the case that mild steel costs what it costs, and it's only getting more expensive to make the shredder blades, and a motor costs what it costs? Not to mention, by the way, my shredder has zero safety functionality, so there should be electronics for safety functionality if there's a hand going in there.
yeah,
Overload protection, I don't have any of that.
yeah.
Um, these are things that, it's not like 3D printers where there can be innovation to drive costs down in terms of, hey, let's injection mold a bunch of the parts and
Mm,
bring the costs down.
yeah,
Do you think
yeah.
that's the case, or do you think there is a way to make a shredder that's cheaper?
Yeah, definitely, it's possible to make it
Yeah.
cheaper, but it's also a question of scale. So of
Yeah.
course, if like if recycling is adopted to the masses by the
Right.
masses, then you're able to mass produce shredders basically, and then the
Right.
costs go down significantly. And right now, we are
Right.
still in a stage in the world where we're still working on awareness. We're still
Yeah.
just on an awareness level in recycling, and
Right.
um, we need to overcome this first barrier.
Well, and I think it's awareness, not the way people would think. When you first said awareness, I was like, but there are some countries, developing countries. I just had a conversation with a good friend of mine whose husband is from South Africa, and when he moved to the U.S., he was like, "Oh, like plastic, the trash isn't burnt here like it is in South Africa. I can put
Yeah,
plastic." But then they had an argument where he was like, okay, but I looked into it, and actually the real awareness issue is people don't realize what you put in the recycling bin is not getting recycled unless it's aluminum or glass. And even still, a lot of glass does not get recycled.
exactly.
Um,
Yeah, that's actually the nice thing about why is it so nice that our systems are in universities?
right.
And one point is what we're actually already seeing. What's quite funny is that now people are getting in touch with recycling during their education.
Yeah.
They actually start to see what it means because, like you said, indeed, before it was just okay. You put it in the recycling bin. All the plastic goes in there. Plastic is plastic, right?
Right.
And that's it. You did your part. But
Right.
uh, if you actually have to deal with the plastic on your own, you start to realize, oh, plastic is not a plastic. Like a little bit of glue or dust can
Yeah. No.
influence the quality. And
And you
um,
have to be so strict that if I
yeah,
see something on a failed print, and I'm not sure, like, oh, is this melted, is this dirt, I throw the whole thing out because I don't have time to angle grind it off. But you start out being like, the shredder will shred it
yeah,
down, I'll have a little particle of 3D gloop. No. And that's my
exactly.
biggest challenge right now as well. As I said, I mean, this print actually failed because of a electronics issue with my Voron and CAN bus. But a lot of my prints are failing for one of two reasons, right? Diameter is tricky, and that's because garbage in, garbage out. But also, clogging is a huge issue. All it takes is,
Mhm.
your shredder is shaving off. I wish I had the roll here. I think it's somewhere actually next to me. All it takes is the shredder shaving off little pieces of metal shavings, which it will do if it's not perfectly aligned.
Mhm.
And all of a sudden, your filament's clogging every half a meter.
Yeah,
Um, so it's really challenging. I'm tempted to pick your brain about how I can make a self-cleaning filter for the ArtMate, but I don't think that's going to be interesting for our audience.
yeah.
Um, so I'll
I
so
would.
I'll kind of come back to this idea of like, what is the scale potential here? Like, do you think I've always said, and I've said to Recycling Fabrique, the guys who are doing filament recycling on a
Oh
big
yeah,
scale in Germany, I actually have a call with them coming up about like, dude, franchise this thing, right?
yeah, yeah,
But but I think it's super interesting with a company like 3Devo. Like when we think franchising, it's probably, a couple machines in the US, one on each coast and a couple in the middle,
yeah,
one machine in Mexico. But if you do this on a smaller scale, like micro franchising, where the investment cost is maybe 5,000 euros, and I set myself up on a directory, like Printables, by the way, has, do you think we get
yeah.
to a point where there's like one or two recycling centers for 3D printing plastic in every city?
Yeah, that's very interesting and absolutely.
Mm-hmm.
Like, there's a lot of misconceptions regarding like I think recycling will only start to take off once it's actually financially feasible as well.
Right.
Like right now, a lot of people see the cost of our machines and are like, "Wow, that's way too expensive." But if you if you have if you send it to a centralized point, for example, like
Yeah.
China, for example, it needs to be collected. You have a sorting center. You have all these people in between. And then at the recycling center, you have staff that need to
Right.
operate all these machines. And then you need to sell this plastic waste or new
Right.
filaments again, which will never be able to compete with virgin plastics, for
That's
example.
exactly. And that's the biggest comment I get is, you know, dude, some filament, I didn't know this because thank you, Polymaker. I don't pay for any filament anymore, but you can get spools for like $11 of
Yeah.
decent filament. I bought from a local company here. This is crazy. I mean, granted, I bought like high performance PLA from Plastics app, um, but I bought pellets, and the pellets here in Israel, where everything's expensive, just the pellets were like $30 a kilo, which is expensive because I
Oh,
bought
wow.
only a few kilos. And
Yeah.
again, it's high perform. Like there's additives in it and all kinds of stuff. But a pellet, like a kilo of PLA pellet should be $6 or something like that if you're buying in bulk, is what I've been told.
Yeah.
And to your point, I think we never get to the point where recycled material is cheaper than virgin, do we? Even if the material is free.
Yeah, well, we could if there's like EU regulations,
Okay.
tax, all of these things are helping. But yeah, realistically, it won't happen. And also, like I mentioned, if it's collected, you collect
Labor.
more issues, like all of these different materials and contamination.
Right.
But what I want to say is, our vision is on-site recycling, so that everyone has access to a recycling system close to where the
Yeah.
plastic waste is generated.
Yeah.
For example, I quite often talk about the case from Audi, the car
Hmm.
manufacturer. They produce so much plastic waste because all the parts to build the cars, they packaging.
Okay.
Um, but at that stage where they take the parts out of the packaging, this plastic waste is quite clean and it's already sorted because it's just a
Right.
uniform stream. So that is the place where it should be recycled, because then you're not putting
Oh
it
my
all in one
gosh,
heap,
yes.
and then it suddenly becomes a lot easier. And this could translate to anywhere, also 3D printing farms, maker spaces. If you're
Right.
able to recycle it on the spot, it becomes it yeah, it stays as clean as possible, and also it generates more awareness because the
Right.
problem is in front of them, because it's not like this abstract concept anymore. They
No.
know, okay, I need to keep it clean because otherwise we cannot reuse it
Yeah,
anymore,
exactly.
and this changes the mindset.
And just to fill people in who like haven't played around and suffered through plastic recycling, like all it takes is one tiny piece of ABS. I mean, when I say tiny, like something like this of ABS in 100 kilos of PLA, you are screwed. It's it. Like once it's shred, it's over. And
Yeah.
like it's happened to me where I'm like literally shredding, and then you smell that because my shredder gets hot because it's a piece of crap, and then you smell
Yeah.
that ABS smell, and you're like, no, like it's over. It's over. Everything is.
Yeah.
It's all garbage. That's it. It's all done.
Yeah. Yeah.
Um,
Yeah.
Here's an interesting thing that I think about, and I'm gonna set up a long-winded question, and then I'm gonna take. This is embarrassing, but I'm gonna take my headphone and I'm gonna run for a bathroom break while you talk a whole bunch because I drink a ton of water, and also I have this sign that I 3D printed, which is taken from an artist I saw in Barcelona, which I thought was really funny. So I have this sign reminder. I just thought that was
Nice.
hilarious. So anyway, I'm gonna set up a long-winded question, and then you're gonna talk for a minute. Before I got into this, one of the areas that I was really interested in was carbon capture. So I don't know if you know, like you can, it's not energy efficient yet, not as efficient as planting trees, but you can actually use equipment to harvest carbon from the air. One of the big problems, though, is what do you do with that carbon? Do you turn it into pellets? And then if you're, I mean, we're talking about metric tons of carbon every day pulled out of the atmosphere, theoretically.
Yeah.
And you need to actually have, the same with plastic, you need to have a market for that carbon if you're going to spend the money of electricity to harvest it, not to mention the equipment, which is extremely expensive. So, sometimes they pump it underground. If there's government subsidies and the government's willing to pay, like, hey, pump the carbon underground into basalt rock 2 kilometers underground, fine. But really what you need is to find industry application, right? Like carbon fiber for aerospace. And I've always thought a filament doesn't need to be 100% plastic. In fact, it in many cases is a lot better if it is 50% or 15% carbon. And I wonder, I don't think either of us, to my knowledge, have a PhD in material science, but I do wonder if it is feasible from a chemistry point of view and also from a thermodynamics point of view to create carbon fibers from pure carbon extracted from the atmosphere in pellets, and then use that for filament, carbon fiber, things like that. Am I totally off base here? And I'll be right back.
Interesting
I still hear
question.
you.
Yeah, all right. Yeah, I don't know the exact science of how carbon fibers are made, but you are right. Like in some cases, it does make sense to add an inert additive to create stiffness in the material, for example. Or what is also interesting in carbon additives is you can make the filament more conductive, for example. So it really depends on the application, I would say. Are you still there? Can you hear me? Oh, you can't talk, of course. Yeah, but yeah, I'm curious, but yeah, can hear you in the background. Yeah, and to be honest, I'm not entirely sure how to answer that question.
I'm back. I was worried that
Okay, that's
question wasn't going to give you enough talking time, but I'm back.
yeah,
Sorry, guys. Biology called. I think it's interesting because also like that's a case where, look, you take a roll of nylon, $40. You take a roll of high temperature nylon, $140. A high temperature carbon fiber nylon, like that. Surely labor is part of that, but like that makes it, you can. And how much actual carbon is in that nylon? 150 grams. Now, I haven't checked in. It's been 3 or 4 years since I researched the space. I'm pretty sure it doesn't cost $100. I think you can remove something like a few kilos. This is a great question for ChatGPT, but it doesn't cost $100 to remove. So that's my thinking. But I also don't understand the chemistry of, how much effort does it take to take pure carbon and weave it into carbon fibers and stuff like that. So
yeah. I'm also
how
not
much
sure.
does it currently cost using carbon capture to remove 1 kilogram of carbon from the atmosphere? This is a couple firsts on this podcast. First bathroom break ever in history, and first cameo from ChatGPT. So currently, with direct air capture technology, it takes between 23 cents and 54 cents. Wow. Yeah, you can remove a metric ton for $540 from the atmosphere.
Oh, wow.
Which is super cool.
Yeah.
And you could make a lot of very expensive filament for that. Now, I want to ask you, Timo, what are people putting in filament? What are some of the cool things you've seen people putting in filament? Because 3Devo machines are designed to help you be able to prototype. But
Absolutely.
Before you answer that, I do really quickly need to thank this episode's sponsor. I just got my little reminder. So this episode is brought to you by PCBWay. Guys, PCBWay makes all the things you could possibly want to make. Besides just PCBs, they do CNC machining. They can machine any material you want. They can do any kind of 3D printing you want, including vacuum casting, polyjet, selective laser sintering. They can do FDM. They can do DLP. But they also can do sheet metal fabrication. They can do electronic design. They can do injection molding. I use them all the time for all different types of CNC stuff, and their pricing is really, really awesome. What I love about PCBWay is I'm not an engineer, and I make mistakes often when I design my parts, and they will actually have a real life engineer look over my parts and then go, hey, you know, this is probably going to warp from the heat when we machine it, right? And then they tell me how to fix it, which has saved me so much hassle. Their pricing is awesome, and you can get $5 off your first order. So I highly recommend, and I use PCBWay. Make sure to check them out using the link in the description. And I think that's a pretty good ad read. All right. Give you some time to think about the question. So what's the kind of cool stuff that people are putting in filaments?
Yeah, well, the first thing that comes to mind is actually they recently got their next generation film maker. It's Lattice Medical, for example. It's a company in France that developed a material for reconstructive tissue engineering.
Wow.
So breast implant basically that is 3D printed with a biocompatible material that basically dissolves in a couple of months' time. But in the meantime, natural fat tissue starts adhering to this
Oh, man.
matrix structure. And this material is completely biocompatible, not harmful to the body. It dissolves into
That's rad.
natural components. And then someone would have a natural breast, basically. So,
What?
yeah, it's insane. So I know they're in clinical trials at the moment, but they produce all these materials on our
Are you
machines.
kidding me? So, wow. So just so I understand, you would 3D print basically a lattice structure of a breast, and you
Yeah,
eliminate the need for breast implants because the body will regrow.
yeah,
What?
yeah, exactly.
Then you take that, okay, 10 years of innovation away. Like, I mean, not to get political here, but like, if someone wants a sex change, can you 3D print a lattice structure and have their body grow the organs that they want to have? Or even not political, okay, if we take that 15 years away, can you regrow a liver, you know, on the other side of someone's body before you
Yeah,
remove? Can we get away with organ transplants? That's a whole new talk about additives. Like,
yeah,
people always say 3D printing organs. We're probably never going to get to the point where you can 3D print a heart. But if you can trick the body into growing its own organs
yeah. Well, I
using,
think
you know, hormones.
in this case it was just fat tissue, though.
Right. But I'm saying
It's just
15
little.
years from now, if you're 3D printing and you're putting in that in the material, you're putting in certain hormones that are causing the body to behave, or stem cells. Again, not a doctor, just kind of
Yeah,
thinking in a sci-fi way. Like, if you can put stem cells or use CRISPR to encode cells from the person's own body, which are like, hey, by the way, I'm a kidney cell, which, by the way, they can do now. Like, they can
yeah, yeah,
take the DNA code of a person and create any kind of cell. This research, by the way, is like strictly forbidden in the US, and it's actually was before the war, very encouraged in Ukraine. So a lot of
yeah,
this stuff is happening like crazy, CRISPR and anyway, but you could theoretically 3D print a plastic that's biocompatible, which has certain kinds of cells from the person's own body. I don't know how you would deal with the heat, but you would encase it. And then the
yeah,
body goes, oh, hey, this lattice structure is actually a kidney. Let's
yeah.
create more. I don't know. I'm
Yeah,
sure
but
my friend who's doing his PhD in this will reach out to me tomorrow and be like, you're an idiot, man. But
yeah,
hey,
that's really the funny thing about 3D printing, right? It sounds so futuristic, but
right.
sooner or later it's gonna be real. And the
That's crazy.
conversation is shifting. If I'm at birthday parties and people ask me, "Hey Timo, what do you do?" I say, "Yeah, I'm in a 3D printing business," and they say, "Oh, can you 3D print pancakes or something?" And I'm like,
Yes.
"Well, probably you can with,
There's a
but you can
machine.
do much, yeah. But
There's
you
a
can
3D
also
printing
do
pancake
implants,
machine.
for example." Yeah,
That's wild, yeah. I just realized I forgot. I hate to jump around topics, but I forgot while we were on the topic of recycling, materials, right? We know we can 3D print ABS. We know, obviously, we can 3D print PET. PLA is not used that much in industry, maybe for disposable stuff. But what about other plastics? Like, I know for a fact that a ton of the plastic we use in our daily lives is HDPE. And I understand that is not 3D printable. Or polypropylene. Like, what are the limitations of, okay, these plastics? Because if anyone's going to be able to recompound polypropylene, it's going to be your customers, right? And find a way to 3D print it. So are there certain plastics that we're using in our day-to-day, like HDPE, PP, PU, that are just not compatible with FDM 3D printing?
Yeah, that's a good question, and it's maybe a nice bridge to what we talked about earlier. HDPE is the most common plastic waste type in the world. The ocean is full of it, actually.
Yes.
And the main challenge with HDPE is its crystallinity of the material. So it tends to shrink when you cool it down after melting it. And this basically makes it impossible to make a nice 3D print, because as soon as you made the first couple of layers, it already warps so much that it
Oh, wow.
uh, separates the layers, or yeah, you have a completely deformed object. And but what you could do though, is if you add, for example, carbon fibers to this material, you make it a lot more stiff, and also the thermal properties also slightly change, making the layer adhesion better. um, then you could actually make something nice out of it. I had some benches on my desk with of which we were able to actually make some nice benches if we added carbon fibers to the HDP.
So imagine carbon capture from the atmosphere, HDPE from the oceans. You're hitting
Yeah,
two birds with one stone. That's
exactly.
wild.
Yeah.
Someone in the comments said, Steve Setback says, printing PP right now. What about polypropylene is used a lot in automotive more than
Yeah.
anything, I think. I guess that's printable. Huh.
Yeah, well, it has similar issues as HDPE, and there's a little bit of a trick, yeah, misconception here as well. Like you can buy PP filaments on the market, but this is different kind of PP than what we
Got it.
see around it, because it's modified with additives to keep it amorphous, so it doesn't shrink as much as other
Okay.
PPs.
Yeah, it's a blend then.
Yeah.
Why is HDPE the most common plastic in the world? I mean, I feel like everything I interact with, admittedly, I don't buy soda or bottled water, so I
Mm.
don't get a lot of bottles, and milk here comes in cartons.
Yeah.
Most of my life, like all the stuff I buy that's plastic is all ABS, right? Very
Yeah.
identifiable. You can kind of look at it quickly and see that it's ABS. Why is HDPE used so much? Do you know?
Yeah, it's an amazing material. It is, and it's super cheap. Like I can name some examples. For example, the chemical resistance of the material is amazing. Like I still remember this episode from Breaking Bad where he has to dispose of the body, and he
Yeah,
specifically asked for it needs to be HDPE. The tray
right.
needs to be HDPE, and he ignores it. He just thinks, "Oh, I'll put it in the bathtub," like
Bathtub.
the acid, and it just the body falls through the bathtub. Um,
Wow.
and also radiation shielding. So it's also used in aeros in space. Um, it's food safe.
Right.
It's
Which
quite
ABS is
impact
clearly not.
resistant. Exactly. So it has
Yeah.
so many benefits.
Yeah. That's interesting. And I imagine it also lends itself very well to injection molding,
Yeah. Exactly.
whereas a lot of materials do not like to be injection molded.
No.
PET is blow formed, like those bottles. They're not I mean, they inject. I think they injection mold just the core, but then to get it to actually form with those thin walls, they have to blow it up.
Exactly.
Whereas HDPE is, I think, injection molded, and then the bottles are friction welded together, half and half,
Yeah. Yeah. Exactly.
which is probably much more efficient of a manufacturing process, if I had to guess.
Yeah. Yeah.
I want to give people. I used to do this when I had a personal development podcast. I don't do it as much anymore. And by the way, guys, ask your questions in the chat because we're coming up. Well, we've still got a little bit of time, but I want to make sure I ask people's questions. when I used to have a personal development podcast, I used to give homework, right? Like, okay, I want people to learn something here today, and I think people have learned a lot, but I want them to act on it. What would be some homework that you would want to give people, either to, lower their footprint in terms of the plastics that they use, or learn something about plastic recycling, or experiment with something? It could be like, hey, try taking your 3D prints and doing this. Or it could be, hey, go on this website and go find one of our customers and bring them your scraps. Is there some homework you could give us where if people are like, hey, F yeah, dude, plastic recycling, this is great, I want them to take an action step this weekend?
It's a good question. I think it starts with identifying the plastics and how they're made. So, for example, just look around you. How many different types of plastic do you see?
Yeah.
That's the first step. Stop seeing plastic as a plastic. There's so many
Yeah.
different types, and even then, what could be interesting homework is um, try to think how is it made. For example, if we see this keyboard, for example,
Yeah.
yeah, how is this manufactured actually?
Yeah.
It's probably injection molded,
Right.
so that will tell us something about the material properties as well.
Right. I'm going to look and see, like, okay, was I right? I was wrong. I held this up and I was like, this is clearly ABS. You can feel and see that it's ABS.
Yeah,
It's not. It's actually polypropylene.
yeah, there you go.
Is there any value? I mean, do they always write the symbol under it? I mean, they write the symbol 5, and then I think they always say PP, so you don't actually need to memorize the numbers, do you?
No, no, no. You can just look up a list, and the numbers. It indicates a special type of polymer or a category of polymer.
But then on things
Um,
like this charger, they don't stamp it at all. Maybe it's stamped inside, but
yeah, I think it's on the. There was a little bit of text.
no, that's just the
Okay.
electronic
Yeah.
standards.
Well, anyways,
It is
I think
that's really good homework, is like
yeah,
identify the plastic is stamped, what isn't. I mean, it all should be. Maybe it's stamped inside.
but I guess that the most interesting. I think most of the viewers are 3D printing enthusiasts,
Right.
so that's what we're focusing on as well now. So there's so many different types of plastic in the world.
Yeah.
But 3D printing is growing, so the waste problem in 3D printing is also growing.
Yeah, yeah.
So, and this is the lowest hanging fruit to focus on first.
Totally.
Because 3D printing material is already suitable for 3D printing. So if you
Right.
recycle it, you know that the material is suitable for 3D printing. So you
Yeah.
just need to take care of
Yeah.
sorting and keeping it clean. So
Yeah, I mean,
yeah,
Recycling Fabrik is only doing Germany, and I don't remember what they told me, but it was an absurd amount. I asked them like, "Hey, you guys have grown a lot since, I first met you 2 years ago now. How
yeah.
how much are you recycling?" And I think it was like a ton a day, maybe. And
Oh
they
wow.
only accept from Germany.
Yeah.
Now, granted, Germany is the largest economy in Europe. It has a lot of, R&D and manufacturing, but
Hmm.
still, that's one
Yeah.
country.
Yeah, that's insane.
It makes you really think, like, how much, okay, if PLA and PETG are just minuscule, how much polypropylene and HDPE are being thrown out every day? And it's like it's thousands of tons a day, probably.
Yeah, definitely, definitely. And also, like, I see on the background, you have a lot of 3D prints, and you have a nice studio to store all of them.
Right.
But many 3D prints, after a couple of weeks, you're done with it,
Right.
and you throw it away. Uh,
Right.
so
Right.
then
Which
it needs
is
to be.
probably a good
Yeah,
time to plug. Prussia has that directory. They make it
yeah,
hard to find, but I can link it later. They have a directory of, like, look up in your city someone who will accept your waste. I accept here, depending on the status of the shredder. Sometimes I turn people away, but I accept PLA waste in Tel Aviv. So
nice.
look up. I'll give some homework as well. Look up and see if there is someone in your city who accepts waste and recycles it.
Yeah.
Really, really interesting. So you talked about the roadmap. You kind of got me very excited because you said, okay, we're kind of shifting and we're looking more and more into 3D printing, recycling, maybe more at scale than
Yeah.
just a company formulating their own formulations and recycling their own. Can you tell us what's next on the roadmap, and maybe people in
Yeah.
the audience can be of value to you either as beta testers or maybe filling out surveys? Like, what are you guys looking at now that you've kind of
Yeah,
conquered that
definitely.
hill of companies who want to grind up and extrude their own really, really high quality filament?
Yeah, so like I said, we really believe in on-site recycling. So we take away all these steps, which saves money to make it financially feasible. But the next step is making it easy, making the process easy. Because if the pain of recycling plastic waste is higher than actually having plastic waste, it will never happen. So that is what we're focusing right now in our R&D development, is basically having a system where you just put in your plastic waste or
Yeah.
your pellet or whatever, and you walk away, and at the end of the day you have filaments to 3D print with.
Yeah.
And in that case, if you're able to do that, and maybe people that have a 3D printing farm is running continuously, maybe there's room for a filament maker
Yeah.
that that is running continuously. And if you don't need to pay any attention to it, there is actually an ROI to it.
Yeah. Yeah. And I do think, as you said, government regulation is going to have to come in to make it cheaper. Like, it's still cheaper to burn fossil fuels, and yet look at China as an example. Like, no one's buying gas cars. It's just too expensive. California as well. Like, it's just, even me here, we have 100% tax on normal cars and only 50 or 60% tax on electric cars.
Yeah.
You want to guess how many electric cars are on the road here? Now we can get into like, where's the energy coming from and but we're gonna have to do something similar with plastics. It's just too cheap to make virgin material.
Yeah. Well, I think the 3D printing materials are still relatively expensive. Like you said, the pellets are cheap. The filaments are still above
Yeah.
10 euros per spool or per kilo. If you are recycling a couple thousand kilos per year, and it's just a plug and play concept of you
Oh
press a
gosh, yes.
button, you walk away,
Yeah.
then it actually becomes financially feasible. And there's no regulations needed at that stage.
I also wonder if we could split up the process, right? Like, I know I'm supposed to be winding the conversation down, but I'm just, it's a topic I care about so much. But I wonder if you could split the process, right? So this YouTuber, Greenboy3D, created a DIY pellet extruder, which, if people don't know, pellet extruders are normally around $3,000 to $5,000. He made one that's like a few $100. Very simple, a lot of 3D printed parts. And I wonder if it becomes a situation where it's like a Nespresso pod situation. I drop off my material and they kind of do their thing, but then they sell it as regrind, not as extruded material. And a lot of people industry already, if you're doing big printing, they're using like Mass Effect pellet extruders. But I wonder if we get to a point where more and more people are willing to just buy pellets and then mix in their own regrind, which is what I'm doing as well. We can kind of solve some of that problem, though. As I said, the extrusion is actually not the hard part. The hard part is the shredding, at least from my experience.
Okay, well, in my experience, the shredding is actually the easiest part.
Really?
But I think it really depends on.
So it's more expensive. Let's put it that way.
Yeah.
The shredding is much more expensive because ultimately the extrusion, if you look at the ArtMay, it's just a 3D printer, except instead of XY motion, it has spooling and what's it called? Like moving along the spool. But it's just
Yeah.
a 3D printer with a 1.7 millimeter nozzle.
Yeah.
And its own kind of modification to the firmware to control flow. And 3D printers are cheap, you know, like that, if anything. And I love you, David, but the ArtMay could be, if this scales up, right, and more people want to make their own filament, the ArtMay could be made. I don't know how expensive CNC machining that high compression sprue is, but it could probably be made for $300 assembled in China. You know what I mean? Whereas, like, as we said, maybe there's some innovation in using gearing, but a powerful motor is always going to be more expensive than stepper motors. Like, I don't know, do you ever see a proper shredder that can give you 4 millimeter granulate getting down to like $500? Is it possible?
I don't think so. And
Right.
because it needs to be powerful, but it also needs to be big enough.
Right.
But the bigger you make the opening and the teeth, the more
Right.
powerful it needs to be.
It also needs safety, like all the things we talked
Needs
about before.
safety.
So then maybe it really does become like, hey, I have a local, just the same way I drop my Nespresso pods off. Like I drop it off, you know, there's small businesses they'll regrind it for me and they'll sell me a kilo of RPLA for, I mean, they would get it for free, right? So sell it for $5 a kilo. And then I mix it in with pellets or print 100% RPLA. I actually do want to get your opinion on that. I've printed 80%, 85%, and 100% recycled material. I'm getting obviously better, more consistent extrusion the more material I put in, but I don't know if that's necessary. Like, what's your thoughts on 100%? Is it worth pursuing as a viable kind of like, is it worth putting in the effort to tune it and work it and try and get the process perfect? Or is it like, hey, from our experience and our customers' experience, it just makes life so much easier to put in, you know, 10 or 15 or 20% virgin material?
Actually, we mainly use 100% recycled materials, actually.
Really?
It is really a matter of getting control over the variables and setting up the right temperature profile in the extruder.
Right.
And that takes some time to figure out what is the correct extrusion profile.
Right.
Once you got that, it's just as easy as mixing it in with virgin materials.
Okay, that's useful because I did get better results, but I think a big part of it is just that at the same time I put in virgin material, I really put in the effort to sort my material better. Meaning, like I said, if a huge part like this has a tiny little bit of glue, it's out. It's not going anywhere near my shredder. There was another thing I wanted to ask you about, and now it's completely evaded me. Guys, ask questions in the chat if you have any other questions. I don't know what it was.
I also had something in my mind, but I suddenly forgot it.
Dialing in, temperatures, recycled material. It's all just very exciting. Thank you. Drying. That's what it was. Drying is a much bigger thing than I had realized with PL. I mean, I just did a video about how, like, within reason, you don't really need to dry PLA filament, but it's a different ball game. One, when you're not talking about 3 months on the shelf, you're talking about 3 years that I've had the regrind sitting here. But also, I think when you shred it and make the surface area so much more, it soaks up so much moisture. You know what made the big difference? Igor from My Tech Fun did an awesome video about, like, hey, could you dry filament in the microwave? Because prior to that, I was leaving it 6-8 hours in a toaster oven here. And, you know, it just wasn't getting the moisture out the same way as 5 or 6 rounds of 30 seconds in a vacuum. And that made such a difference in the material. You can see it's still got a little moisture in it, but like the actual filament now doesn't look like carbon fiber filament because there's so many pockmarks on it. How do you guys deal with drying specifically? Because your customers are grinding up filament. You can't just put it in a filament dryer. it will
No.
fly everywhere. And if you put it in an oven, it can often melt because, again, so much surface area absorbing the heat.
Yeah, so there's a couple of options. A regular kitchen oven, it does the job. So you
Okay.
just load it on a tray. In many cases, you do need to set the temperatures a little bit lower than usual
Yeah.
for the polymer. Um, but yeah, like you said, if you don't dry the material properly, the material will degrade once you
Big
start
time.
processing it. On an industrial scale and a more research scale, they often use desiccant dryers, for example, or
Really?
vacuum dryers. Yeah, or
S-
even dew point dryers.
okay. That's interesting. Vacuum, I've seen that Stefan does with his vacuum dryer. It's an interesting idea, and I wonder if there's a way, in the same way that I've kind of like, there's a saying in Russian, like you build something with shit and sticks. Like my shredder is built with shit and sticks, and I wonder if there's a
Yeah,
shit and sticks way to make a vacuum chamber out of, an old keg or something metal that will hold. Creating suction is not hard.
no,
It's an
yeah.
interesting idea.
To be honest, I don't think it's worth the time. Like if you
Really,
look around, if you're ever in the Netherlands, please come by our office
I
because
would
we have
love to.
tons of prototypes, and that's basically an R&D playground there. And of course, we tested different drying concepts like vacuum drying.
Okay.
And what we found out is that the building the system was so complex, and the difference in results was not that big because
Yeah.
for 3D printing you just do it on a small scale.
Right.
So it doesn't need to come down to the decimals in terms of moisture content.
Right.
You just need it to be dry enough to get a decent printing quality in the end.
Yeah, and like I said, the microwave technique, obviously anything with carbon fiber, complete no go, right? It's sparse. But it works shockingly well. It sounds stupid, but I mean, you can literally you open the microwave and just a ton of moisture comes out, like steam basically.
Yeah.
It's shocking how well it works. The only thing is it's frustrating, and it's also I've melted. Microwaves don't heat evenly.
Hmm.
So I wonder, there could be a really cool solution. I'm just thinking out loud because we're playing now, right?
Yeah.
It could be really cool to take an Arduino, hook it up to a outlet thing, and do 30 seconds on, 2 minutes off, just controlling the AC power going into the microwave.
Well, we were thinking of like you have these small convection ovens with a spit function or spit roast.
Oh, okay, yeah,
So with like a rotating stick in the middle, you
yeah,
could make like a drum in there,
yeah.
just like a dryer, a drum, and you put your pellets in there or you regrind,
That's
and
interesting.
then it just keeps rotating while the oven is turned
I
on.
was thinking about doing something exactly like that because, as I said, you can't use a traditional filament dryer. It'll shoot flakes everywhere. But then I kind of had this realization of, in terms of energy efficiency, if you heat an oven, you're heating all the metal of the oven. You're using a ton of energy to
Yeah.
heat that. It's kind of like a car. If you think about a internal combustion engine, 97% of the energy is just to move the mass of the car. Only 3% moves the actual
Yeah.
passenger. Here it's the same. Whereas with a microwave, you're not using any energy to actually heat the microwave. Again, non-starter for carbon fiber filaments or anything like that. But for the average consumer, it's going to be much more energy efficient to just dry it in a microwave.
Yeah,
But
definitely.
it's not perfect. It's also not perfect, is what I've realized.
Yeah. Yeah. Yeah, I think maybe the best solution would just to be once you have the plastic waste, just keep it in a sealed environment. Throw
Yeah,
some desiccant bags in there, and just prevent it from taking up too much moisture. Because then you don't need to dry it as long, and
yeah,
you don't need to waste so much energy.
true, true.
Um, yeah, what is
Awesome.
also interesting, like we also have some clients that recycle their SLS powder waste, for example.
Oh, wow.
It's nylon powder, and we first thought, oh, that needs to be dried very well because nylon takes up
Right.
moisture. But we figured out that because the SLS powder or MGF powder is so compact, uh, that it doesn't allow air and moisture to
Oh,
enter the material. So because it's so compact, you don't even need to dry it before turning it into filament or
that's
recycling
mind
it.
blowing.
Yeah.
That's mind blowing. Huh. I love it. By the way, I want to report that I'll just switch to this screen share. My RPLA is doing a fantastic job. Look at that massive part. Now it's worth note. You can't see this, unfortunately. I think maybe I can screen share here. Nope. It's a big part. Unfortunately, I can only print with a 0.8 millimeter nozzle because my filament is just not clean enough. But I think as the shredder breaks in and stops shedding plastic or shedding metal, I think I might be able to get it to 0.6. I don't think I'll ever try 0.4. That's like the you'd have to have everything sealed at all times, no dust, no nothing. But I'm pretty happy with that. Fingers crossed my Voron doesn't have like a timing issue again. Timo, you've been very generous with your time. I feel like you and I could talk for hours and hours and hours, and I will take you up on that next time I'm in Europe. I'm going to pop over and we'll play. How
Nice.
can people support you guys? I know a lot of our audience, one of the reasons we decided not to do a collaboration and have you guys send over a machine is, flat out, my audience is 92% consumer. But how can we support you and also maybe convince you to create consumer machines for us?
Yeah, I think it starts with what you mentioned, centralized points,
Right.
perhaps. But yeah, I think just think outside of the box, right?
Yeah.
Material is a variable as well. So you have 3D printing. The mindset is in there in people's minds currently, but
Right.
the mindset of material, it still needs to come. Like, okay, what do I do if I dispose of this material? Can I recycle it? Can I turn it into something new? Or wait a minute, I need specific properties of a material. Can I make this material? And
Yeah.
and yeah, this is what we do basically. We open up this new possibility.
Yeah. And I'm putting the link in the chat as well for folks who want to see this Prusa directory. It does already exist. Let me just show everyone. So there is a directory that shows all the different recycling centers in the world. No, that's users, 83,000 users. But if you click 3D print recycling, waste recycling, you've got you've got one in Israel, which is me. Which is a shame because I know there are filament manufacturers in Israel. They just don't want to contaminate their lines, but fine. You've got one in Israel, but there are centers. You've got one in, it looks like, Bulgaria. So check this map out, guys. You've got one in, is that Montenegro or is that Croatia? One in Croatia. And then you got a ton in Europe. So if you're in Europe, you've got all kinds of recycling centers. I will link this in the description. You've got 3 on the east coast of the US. You've got 2 in Los Angeles. But there aren't enough, to your point. Like, I think if someone creates a business model, right, and a brand and a standard.
Yeah, I actually heard someone say on Formnext last year, like, why aren't we able to buy filaments at hardware stores?
Yeah.
And what if every hardware store had a filament maker or a shredder? That will be so
Yeah.
cool.
And not a big outlay. Like, okay, if someone's listening, I keep almost ending the podcast and then not. Tell me if you have to go. If someone is listening and is like, hell yeah, I'm going to start a business. I'm going to start collecting people's scrap waste and selling it as my own filament. Like, what's the minimum investment right now to do that with 3Devo products?
Yeah, yeah, you would need at least 20,000 euros.
Wow.
So
Okay.
it's quite an investment if you're just by yourself. So like I said earlier, it's really, you need to have a proper business plan basically. Okay, uh, how much time are you going to invest? How much plastic waste are you actually recycling. And yeah, if this is your only business, yeah, it's quite a big risk. So
Right.
I think it's really nice for people that already have a 3D printing farm, for example,
Right.
um, or
Right.
maybe a community that more people can use it.
Right.
Because it doesn't really make sense if you only have 20 kg per month, for example.
Yeah.
You need good volumes.
And I think, like, look, if you're going to set up your own business and you're not an already going business, like, with all due respect to 3Devo, probably your better route is a similar route to I went without all the mistakes, which is precious plastic, open source, shredder, probably pro. Build it yourself. Maybe go with the 3Devo extruder because you need something that can scale, and the ArtMay is great, but you can't, you can really only do, like, I think a kilo every hour and a half or 2 hours or something like that. But you could bring those costs down a lot if you're willing to do the work, do the research, do the, legwork to find parts. I'm just thinking, like, I really wanna solve this problem for people. Like, there are a lot of members of my audience who watch the videos and are like, I would love to do this. This would be an amazing side hustle. But as you said, $20,000, that's like take out a business loan. Not to mention you need somewhere to do it.
Yeah. Yeah, and it takes time.
Well, time, I don't know, because with the 3Devo machines, not to like advertise your products, but as you said, I could load in 10 kilos of filament, come back, at lunch, load in another 10 kilos. I'm saying for shredding.
Yeah.
For extruding, yeah, someone needs, unless you're doing 10 kilo spools, you need to be there every hour.
Yeah, exactly. Yeah, it could be interesting if you have like a community. And so our next generation filmmaker, not trying to sell
Sure.
it too much, but we just launched it. You can have several of the filmmakers lined up. So instead of having one extruder, you could have 20 filament makers and have like an extrusion farm, basically. That you all control from one central computer, for example.
No
So
shit.
you can have
Let me pull that up.
every filament maker producing a different kind of material or a different color or whatever. And yeah,
Which one is that? Let's look. Explore filament makers.
the filmmaker 2.
Okay, I saw this one at Formnext. It's not like
Yeah,
just launched.
exactly.
Yeah. And what's the difference between the 2 and the 1?
Whew. Basically, everything changed. So it's
Okay.
been 8 years since we launched the 1, and we
Okay.
basically collected feedback from all our existing clients, and we tried to cramp it all into one. But I think
Wow.
the main thing is that it's really making it even more accessible. The quality is of course higher, but ease of use, basically the concept of pressing a button, plug and play solution to make your own filaments, that is the most important thing.
Amazing. And I don't know if like people need to get a quote, but what does this one cost, if you can share?
Yeah, this one starts at 17,000 euros.
Oh wow. Okay.
Yeah.
So I thought the shredder was like the majority of the 20,000 startup cost, but no, this is
Yeah,
a big
no,
part of it.
yeah.
Wow. And how much, like, how long does it, how many kilos can I make an hour here?
Yeah, so the main limitation is it's such a compact system. So you need to cool down the material.
Yeah.
So you need with a cooling path extension, you can process 1 kilo per hour on
Okay.
this machine. But yeah, I can also process 3 kilogram spools. So basically, yeah, then it starts to become a nice thing. You just start it up in a couple of hours. You take off the 3 kilogram spool, and that's it.
Yeah. Amazing. Okay, so for consumers, for now at least, probably stick with the ArtMay for 700 euros.
Yeah.
But scale up to this. But we still need to solve, Timo, the shredding issue. The desktop
Yeah.
shredding issue.
Yeah.
But until then, Timo, thanks so much for coming on the podcast. This has been really a pleasure. And I'm super passionate about recycling, so you're always welcome to come back on the show. I know my audience cares about this quite a bit. And let's just keep in touch and talk about ways that we can, I mean, I bring zero engineering experience, but I do bring an audience of people who are passionate about this. And if we can put together my audience with the amazing engineering work that you guys are doing there and somehow save a lot of plastic from landfills, that would make me very happy. And I think that would be a successful collaboration. So let's continue to be in touch.
Definitely. Thanks for having me, Jonathan.
My
It's been
absolute
a pleasure.
I'll take us out and we can debrief. Take care, everyone. Thanks for tuning in live. See ya.
Bye-bye.
Thanks for tuning in to the Infill Podcast. For show notes or links to anything mentioned in today's episode, visit thenextlayer.com. If you enjoyed the episode, please don't forget to leave us a review wherever you're listening, or click the like button to let us know. And consider subscribing to The Next Layer on YouTube so you can tune in live and participate in the next conversation. We'll see you on The Next Layer.